Again, I'm Jide Osan, and I'm here with Ian Stewart, and we're from Squareknot, and we're here to talk to you about Vue and application state. I see that a lot of people like to use Twitter, so you can follow me at Jide Osan. I don't really use my Twitter. I have like 2 followers, my boss and my mom. So you should actually follow Ian, because he actually tweets a lot more than I do. And he is at Ian M. Stew. Or you can shoot us an email. I'm Jide at Squareknot.com, and Ian is Ian at Squareknot.com. So what is Squareknot? Squareknot is a way to make beautiful, branching step-by-step guides in your browser. So on Squareknot, you can learn how to bake cupcakes, how to change your oil. You can actually plan out a trip to Rome if you wanted to. You can learn how to play the guitar. I actually just put up a project on Squareknot about setting up like a Raspberry Pi, so that was cool. But basically anything that can be described in a sequence of steps can have its home on Squareknot. So the internet is really, really good at telling you about things. You know, you can learn about buildings and people and all that stuff. But when it comes to actually showing you how to do something, the internet kind of sucks at it. So on Squareknot, you can go and you can find a project on topics that interest you, and you can do them by following the steps. But the real beautiful thing about Squareknot is the level of interactivity you get with the actual content. So I know when I go on blogs, and maybe it's like a cooking blog, and I want to learn how to cook something, I'll follow the blog, but usually I don't always follow all the directions. Sometimes, like in the comment section, one guy is like, oh, use baking soda instead of baking powder, or something like that. And you'll find a lot of great information in the comment section. But what Squareknot does is all those suggestions are actually baked into the interface. So at any point in one of these projects, if someone wants to make a suggestion, they can actually branch off the guide and add their own steps. And their project will inherit the previous steps on the project, the project that they branched off of. They can also extend projects too. Yeah, and so at Squareknot, we really believe that everyone has something to offer. And our core philosophy is that we can learn a lot from each other by sharing our ideas and collaboratively working together to improve them. So in short, Squareknot is basically GitHub for things that you do. So I'm going to demo Squareknot a little bit. So this is the home page. We're still kind of in stealth mode a bit. So let me just go down here. These are some of our featured projects. There is this Make a Lemonade project, which is pretty cool. So when you get here, you first see the project overview, which has the supplies and everything that title and description about making lemonade. So first, and this is our interface. So there's steps that have pictures and titles and descriptions, and they also have supplies, so you actually see some of the supplies, and you can actually have comments on each step. We have pictures. You can also post videos on Squareknot. You can just have a text step if you wanted to. And then the cool thing about Squareknot is the branching interface. So if I got to this step 4, and I decided, okay, this is adding simple syrup, but I don't want to use syrup, I can actually look at this project over here that's saying make a sugarless lemonade. And it's telling me the steps that I have to add, the new supplies that I have to add. So now I need some stevia, and I need another lemon and a knife. So I can actually go ahead and select this branch. And all of the new steps will actually just fall right in, and I can continue this project. You can also put like audio. So in a nutshell, that is Squareknot. So when we first got the mock-ups from the designers and sort of the interface with all the animations, we had to boil it down to a couple of really core requirements. So the first one is there are 3 application states. So there's that overview that you see, and then when you scroll down, there's steps. And then when you start branching, you'll notice that some of those nodes, they'll start to change. So there's the overview state, there's the step state, and then there's the branching state for the overall application. And then there's also the component state. So like each step actually has its own state. You'll notice like maybe when you scroll down to a state, if it has branches, those branches will fade in. Sometimes we might want to preload some stuff. So when you get to that step, your stuff is loaded. We're going to load everything. And then some of the nodes need to know, like, okay, if I'm branching here, I'll just show you. Like this one. If I'm branching, like this node kind of converts to this state, and then when we cancel, it goes back. So these are just views, and they just have different states. So then there's the component state, and they're all based on the application. So if I'm on one step up here, a node all the way down on the project knows that I'm not focused on you right now, so it might be faded out. But the node at the top, close to the top, that is in focus, it has to know that it is in focus. So it has to have the right state. And then finally, the states are all based on, the state has to be based on data models and user interaction. I'm going to dive a little bit more into that a little bit later. So these requirements, they basically forced us to rethink our architecture and develop a new architecture which focuses on state. And Ian's going to talk about that.
So in working closely with the Marionette team, especially on Gitter, if you haven't checked that out, highly recommend it. I've entertained lots of conversations about best practices for views, nesting views, modules, making views modular, separation of concerns. And so, and a personal passion of mine linked with these best practices is that you've got this idea of a component, and a component is able to manage the state of its views and be nested within other views. And this component is also capable of advertising business events to the application. And a lot of blog posts and a screencast out there covers about one level deep in that nesting structure. You've got you generally have a controller that receives that has handlers for routes, and then you create views off of that, and hopefully you're good. But as you saw in our case, we've got 3 levels of highly interactive views to deal with. So I wanted an architecture that we wanted an architecture, and I was like personally really passionate about an architecture that would allow us to nest these ideas of state and enforce separation of concerns. So we did a lot of research in stateful architecture, and just beginning with the core backbone philosophy of views bound to a model and a view updates when its model changes. That's a great place to start. The key rule of this, which many people shortcut within reason, and I think it's acceptable, but we're just sticklers for logical completion and perfection. So the key rule that comes out of this philosophy is that each and every change to the DOM corresponds to a model change first. And we wanted a decoupled implementation where the view's only responsible for simple, in fact, really dumb updates, and for broadcasting user interactions based on DOM events. So what to do with all that presentation logic? What happens from the time a user clicks a button and says, a button click event is fired to the point that we have actionable state information that a view can react to? We need a container that handles user interactions and updates the state for those views. And after a lot of research and our own experimentation, in fact, it didn't start out this way, it ended up this way, and a lot of collaboration between the 2 of us, we came up with this idea of a state service. So And it's not new. You've heard it before in terms of a controller, perhaps. So you have a view component or a component, and it's advertising business events. In our case, the steps as you scroll advertise, hey, I'm active. Tell the project system I'm active. Then the other steps will fall into line. Or, hey, I'm in branching mode. So those would be business events. Now the state service has its own state model, and it will apply some different business logic and then arrive at a final state. So for example, as we're scrolling down here, right now step 3 is active. No other step is active, and you can kind of get a peek at 4, it's inactive. And once it comes into focus, step 4 is now active and 3 is no longer. So that's the type of logic we're talking about. And there's actually an attribute, a state attribute called mode. And one mode is active and one mode's inactive. So that's great. Now that row is a layout view. And that layout view responds to changes in the mode. So that's cool. But what about the nodes? Actually, I'll get to that in a bit. So we're going to apply, we wanted, this is high level enough that it could be applied to application level logic and also component logic and view logic. And we're going to start at the top with the application logic.
So yeah, our first implementation of this unidirectional state architecture was at the highest level, and it was on the application state. And this is where, I don't know if I said this before, but we are talking about the project viewer in this case. So basically, we have the component, and the component would send a business request to the state service. The state service would make changes to the state model. In this case, the project state service is sort of a black box. I'm going to get into that. But it will make changes to the state model, and then the component will it would update based on changes to the state model. So this was our first implementation. So I'm going to talk a little bit about this black box. We kind of had to come up with a black box in this case because there's a lot of things that are going on at this high level. A lot of the complexity is baked into there, and we didn't want to have too much of that complexity dealing with data on the in the components level. So we pushed a lot of it into the application state. So the project state service has a domain service which creates and manages persisted entities. So like, the project model in our case, which has a title, description, all that stuff. Then we have like a steps collection, which is a collection of each step. I'll actually show some code here. So in this case, this is our domain service. It's really simple. It has it has a channel. We're using radio, marionette radio in that case, and yeah, it just has a bunch of setters and getters for the entities. There's not really a lot going on here. And then we have our use case service, which handles a lot of the business events. So our use case service, it actually, again, it's also using radio. It just sets up some listeners on the project channel, and that's how the components basically communicate with this high-level state service through radio. And also, the use case service, you can request entities. So when like a module, when a component is initialized, it might need the project state. You can actually get that over the channel. So, and then finally, we had this finite state machine, which is where a lot of the computing for the state comes from. In this case, the state has to be based on the user's interaction with the project system and with the domain. So what data is currently within the domain. So I'm going to. So this was the state machine that we used, and again the goal was to compute state based on domain and user interactions. So these are just the high-level states of the project system. It has a step state, overview state, and a branch state. And you'll see all of these these arrows are user interactions based on the current state that's there. So like, for example, in the step state, if a user were to scroll up and the data says, hey, there is a step above the current step that you're on, then you're going to continue to be in the step state. You'll be in a different step, but you're still in the step state. And maybe if the user continues scrolling up and there is no previous step, then they're going to be in the overview state. Going from same thing, going from like the step state to the branches state. If they click on a branch, now you're in this branches state. When you look at the application, sort of the application as a whole, it might not be obvious why each one of these things are necessary, especially for the project state service. But we found that it was really, really crucial to track each one of these states when we start getting down into the components. And Ian's going to talk a little bit about that.
So this is obviously, we're talking a ton about state. And what Jide did to arrive at this is he drew a state map on a whiteboard covering the interaction designer's various states in the mockup, and then what links them from one state to the next. And he did this until he was satisfied. And what's interesting is if you follow the backbone philosophy to its logical conclusion, and every change in the DOM begins with a state change in a model, then solving a backbone app is really solving a state. It's really your app is really a state map, and that's what Jide did at the top level with the application. If you can come up with the state attributes for your app and what's involved in changing those attributes, then your views are literally just updating. That's it, and advertising, hey, someone clicked me. And that's really what we wanted to do, to compartmentalize that business logic. And so Jide masterminded that at the application level, and he did it so well. That very top level architecture we discussed, the black box of the state service, worked so well. I actually let him debug the finite state machine because I really didn't have to get my hands in there at all. I was just advertising events on the business channel and then reacting to changes on the project state. That was it. Now, on my side, I got into component state. So, I will say, we're going to be showing you some nesting here, and it looks complex, but when I show you the code, you'll see how incredibly clean and compartmentalized it is, and hopefully it'll start to make a little more sense. Because right now, you're like, wow, that's a lot of arrows, a lot of boxes, and we're not even done yet. So, application state service, this is where what Jide just explained was that big black box with the finite state machine and everything. But this component down here really doesn't care what's inside. All it cares is that it has some place to yell at when the user does something. And then this component will also react to changes. Now within that component, it has its own state. It's keeping track of its own state. And we're doing it with a separate state model, but that's not necessary. You could use one model. You don't have to break it out. But we had so much interactivity, we wanted to keep interactive states separate. So we have a data model and a state model going down all the way to all through our views. So the state, we've got that same cycle happening within this component. Within a step, you've got business events hitting the step state service, changes going to the step state model, and then state events going back to the view. Those would be model change events. And so this is actually what it looks like. And I really hope when you see the code that that you'll feel a little less scared. But this is that infinite nestability that we're talking about, and how each level is completely self-contained and modular. This idea of a component can advertise business events, in this case on the Backbone radio channel, and also its own internal event system. So, and I'll give you an example of that in a second. Hopefully this will come together for you in a second. But I hope you can see that really, you just replace this component view box with another state service driven component, and you can keep going forever, theoretically, with each level only taking care of its own concerns. So here at the step, we're treating the state service as the component. This is the logical definition of the component, because views are only responsible for rendering that state. So the logical definition of the component is held in the state service. And I'm going to look at only one attribute, because this is the one that has the highest impact. The step can be active, inactive, branching, or hidden. How do we calculate that? Well, whenever the application level changes its state, we trigger the set mode method. Let's jump down here. Set mode grabs everything it needs to know to calculate the resulting state at the top, and then right here, this is all of the business logic for arriving at either branching, hidden, inactive, or active. That's it. If the project's in a branching state, go here. If it's not, go there. Is my row the active row? If it is, then I'm in branching mode. Now, in branching mode, steps that follow are hidden. So that's where this is taken. That's where this comes into effect, right in here. Otherwise, I'm inactive. This almost reads like English, and the only state we're concerned with is the step. That's it. Now, the step layout binds to its own internal state there. And so when the mode changes, here's the different cases. Active, inactive, actually we don't do anything. Branching, we do a scroll animation and we add a class. And if it's hidden, we hide. But these obviously, actually active and inactive have more of an effect for its children than it does for this class, but we can always hook into them here if we want to. Again, we're not worried about our children in this case. We're only worried about myself. And then what we do is we pass, in onShow, we pass our own state down to its children. And that's where the children can pick up and learn whether or not they are in, their parent is active or inactive. And that's going to make a big difference. Back to this diagram, that is what we have coming in here. So the step state model is being passed into the node. So now the node has its own mode. It can be in step, overview, hybrid, or hidden. And you saw all of these demonstrated just as Jide was clicking around. And it looked effortless, but obviously it's not, because it took all of this to make it elegant. But here we have when we're going to change our own mode, the node mode, when the step, when any of these events happen on the parent. And what's interesting, so whenever the parent mode changes, we're going to recalculate the internal mode. And it doesn't matter if we recalculate more often than is necessary, because we're using a backbone model and we'll only react. It'll only fire change events when something changes. So these are all the cases, all the dependencies on when I might need to change my mode. So down here in set mode, again, it's a very we get any data we need to make that calculation, and then the calculation is just this simple. If If I'm column number 0, I'm automatically in one mode. If I'm not, then take a look at the parent. If the parent's inactive, then I'm hidden. If the parent's active, then I'm in overview. If the parent's in branching, then it depends. Am I the active column? And at the very bottom of that handler, we're just updating the internal state. And as a result of that update, the node layout has another switch, and all that we're doing is replacing the class name. So it's a very inexpensive operation to change the mode. We're not even re-rendering. We really only re-render when the data changes. If the state's changing, we just use class names. And because we found ourselves reusing this concept, we created a library called Marionette State Service. And this is taking a few steps back again. It doesn't do very much. All it does is it has a state model, it's a container for business logic, and it has convenience methods for updating that state model. So you would initialize it with your default state. You would bind handlers to any events or model changes that are coming in, just like I did, and you've got methods that delegate to the underlying state model. And if you want to take a closer look at it, it's up on GitHub underneath the Squareknot organization. It's on NPM and Bower, and there's some really cool example cases of how to use it and how that architecture might be useful for you in the detailed write-up.